So hello and welcome to the continued coverage of the walkthrough series, and in this episode we're looking at 9618 variant 42 of October-November 2023. We will be doing the Java implementation to question 1 of this paper. Alright, so let's go ahead and scroll down to where the question is. So we are given a source file that we are going to use to answer question number 1. It's called stack data. Then what I did was to, since I'm doing, I'm keeping all my project files in the same folder as it were. So there is a clash in terms of the file names. So there was this stack data file. It's for another paper. I'm not really sure which one, but I actually covered it. It's one of the videos that I've done so far. So as it happens now, this paper that we are currently covering also is a stack data file, is it? But you see that the contents are different. So what I did for this one was to label it an N23 at the end, so that it's different from this one, so that you won't have to load the wrong file, as it were. So that's what I did. So my text file is not stack data, but it's actually stack data N23. All right, so let's go ahead and look at the question. So it says here that a program stores lowercase letters in 2 stacks. One stack stores vowels, that is A, E, I, O, U, and one stack stores consonants, that is letters that are not vowels. Then each stack is implemented as a 1D array. Then the first part right here requires us to write a program that's going to declare 2 1D global arrays, stack vowel and stack consonant. Then each stack needs to, rather each array needs to store up to 100 letters. The index of the first element in each array is 0. Then if you are writing in Python, of which we are not doing that. So let's just go ahead and look at the solution. So here you see that I have my number 1A, item 1 solution between lines 10 and lines 11. Is it? So they are global in the sense that they've been declared outside of any methods. So it means that any method that resides inside of this class is actually going to have access to these global arrays. And then of course you can see that the data type is character. Then of course you can go ahead and copy this code and paste it inside of the evidence document. Then moving on, you have item number 2. It requires us to write program code to declare and initialize the 2 variables. So the 2 variables that we need to declare are vowel top and consonant top. Basically, these are the pointers to our stacks, as it were, right? Or you can call them, you can think of them as the stack pointers in this case, but we're just calling them vowel top and consonant top. And each pointer is actually going to point to the respective stack, as it were. So vowel is going to be used inside of the stack vowel, and consonant is going to be used inside of the stack consonant. So let's go ahead and look at that implementation. So it's quite easy. Again, you're just declaring 2 variables of type integer, then assigning and initializing them with values of 0. So you see this implementation on lines 14 and 15 for me right here. Then of course you can go ahead and copy the code and paste it inside of the evidence document. All right, so moving on, item number 3, we have a procedure called push data. It's going to take 1 letter as a parameter. Then if the parameter is a vowel, it is pushed to the stack vowel, onto the stack vowel rather, and the relevant pointer is updated. If the stack is full, a suitable message is output. If the parameter is a consonant, it is pushed onto the stack consonant and the relevant pointer is updated. If the stack is full, a suitable message is output. You do not need to validate the parameter is a letter. Then write program code for push data. So the push data method, I have it going on at lines 18 through 34. So you see that we are taking the function header, we are taking the character parameter right there on lines 18. Then of course it's a void function because we weren't told that it's going to return anything. So that's how you know that it's a void function. Then on line 19, I actually did something here. Instead of having to use an if statement to validate that the letter that was supplied by the user when they call this push data function is a vowel, I did create something called a helper method visit. So this is one thing that you might actually start to realize as you progress with your programming journey, that sometimes you want to keep your code lean and clean. So keep the code clean and clean in this case, instead of having to test if a letter is a vowel, I just created something called the helper method that's going to actually help me validate or rather check to see if the given letter is a vowel. So on line 37 to 39, it's a very simple method, but it has a bit of syntax that might look strange to you, but I'll just explain what's going on. So it's a private static boolean method, meaning to say that it's going to return a boolean. Then it takes a character as a parameter, right there on line 7. Then inside of the function body, we are going to return a boolean, right? But the boolean is going to be evaluated this way. I have this string a, e, I, o, u, right? So you remember that these values have index 0, 1, 2, 3, 4, because a string is just a character array. Then I'm now using the index of method that is used on strings. So as you can see, if I hover over this index of method, it says here that it's going to return the index within this string of the first occurrence of the specified character, right? So the character that would have been passed, right? Let's say the character that was passed as an argument was, let's say, the letter X, right? And clearly you see that we do not have the letter X right here. So this means that the index of letter X is not going to be found. So it's going to be -1 because it's out of the specified index ranges. So essentially it's going to return a Boolean false as it were. Then let's say if the letter C, the character that was passed was the letter, let's say I, so you'll see that I is actually on index position 2. So it means that the index of the letter E is actually it's actually going to be the letter 2, and 2 is not equal to -1. So in that case, it's going to return a true. So this is how this helper method works. So it's just going to help me validate whether a given letter is a consonant or a vowel. So after declaring this helper method, now I'm using it on line 19. So remember, is vowel returns a boolean true or false. So we are simply going to pass the letter that was passed as an argument on line 18 right there. Then if it returns a true, then it means it's going to run the code that is inside of this particular section. Then if it is false, then it's going to run the code that is inside of this else statement section right there. So what we have going on inside between lines 20 and 24, we are simply checking to see if the current pointer is less than the length of the stake vowel. So if it is less than the length of the stake vowel, it means that we still have space inside of the stake as it were. So we can go ahead and take that later and push it onto the stake. Then of course we need to update the vowel top pointer as it were, because we've just added an element, so we need it to point to the next available slot as it were. Otherwise, if we don't have any space, it's just going to output the vowel stake is full. Then of course for the consonant top, we're now just it's actually just the same logic, but we're just doing it for the consonant. So this is the push data method. Then of course you go ahead and copy the code and paste it inside of the evidence document. Then moving on to item 2, the stake data txt file stores under lowercase letters. Then I'm just going to open it so that you can see it. So remember I said I called my file November stake data n23 for November 2023. So you actually see this is the file right here. So you see that there's a bunch of letters going on in there. So what we need to do is we need to create a procedure called read data that's going to read each letter from the file, and it's going to use push data to push each letter onto its appropriate stack, depending on whether it's a consonant or a vowel. So what we are doing for this one is we have the I have it up here, read data right there. All right, so lines 42 to lines 56, that's where we have the read data function. So you see that we are creating a buffered reader object on lines 43, as well as let me just format here so that it's on a new line. Format document. Let me just take this buffered reader object so that it won't confuse you guys. If I do this, then I can come and put it right here. Actually, I need to have that going on there. So it's giving me an error. So let me just take it inside of this track so that format document. Still giving me an error. BR cannot be resolved. I just created. Okay, let me just take it back to where it was. And just undo a couple times. So we are basically creating a buffered reader object called BR. Then remember that the buffered reader constructor needs to take a file reader uh, object as it is. So that's what we are doing. And also you have to pass the file that you want to read inside of there. Then on lines 44, we are now creating an empty string. Rather, it's just a now string called current. Basically, this is what we are going to use to hold the current line that we are reading from the file. So we are now calling the buffered reader objects to read the current line, then storing that current line inside of this current variable that we declared on line 44. And basically, we're just checking to see if it is not equal to now. So if it is not equal to now, that then it definitely means that there's something on that particular line. So we are going to go ahead and run the body of the loop. So inside of the loop, what we are doing is we are declaring a character called letter, and basically we are now taking the current string, because remember the BR, the buffered reader object, whatever it reads from the file, it's actually going to be of type string, is it? So we need a way to convert it to a character, and basically since we know that each line inside of the file is just a single character, we are just going to take the character at index position 0, which is the only character that is inside of that particular string, and then we are storing it inside of this letter variable right there on line 46. Then on line 47, we are using the character wrapper class and checking to see if the given letter that we have converted to a character is actually a letter, is it? Then of course they said that you don't need to do this, so you would actually just get rid of this if statement and just go and push the letter onto the stack as it were. It would still work, but I just wanted to show you how simple it is, right, to validate whether a given character is a letter or not. This is actually just a built-in function. It's inside of the character wrapper class as it were, so you can actually validate to see whether it's a letter or not if you wanted to. It's that easy. Then of course we are using exception handling in the event that we have an error reading from the file, or we have an error. So this one is file not found. Rather, let me I want to say file not found. Yeah, did not. Maybe let me say did not find the file. Then I can just write the message right there, so that at least my errors are different. So we are just using exception handling in the case that we do not find the file, or we are unable to read from the file. So the file not found is thrown by this file reader class. You can see here, you just override it. It shows that it throws a file not found exception. Then this IO exception is thrown by this buffered reader class. So you can see that unfortunately it's not showing here, but it's going to be shown thrown by the buffered reader class as it will. Then of course you go ahead and copy the code and paste it inside of the evidence document. Moving on to part C, we have a function called pop vowel, which essentially removes and returns the data at the top of the stack and updates the relevant pointers. Then pop consonant actually does the same thing. Then if the stack is empty, the string no data must be returned. Then already that's how you know that your string is actually your method is actually going to return a string, is it? So write program code to declare pop vowel and pop consonant. Right? So let's go ahead and look at the implementation here. So this is the implementation for both methods, pop vowel and pop consonant. Again, you see that it's exactly the same implementation. It's only the variable, rather the identifiers for the functions that are different. And what we are doing is we are specifying the return type on the function header. It's going to return a string. Then if the vowel top is equal to 0, then it means that we don't have anything on the stack, so we cannot pop if the stack is empty. Otherwise, we are going to decrement the vowel pointer because we are going to return or remove the element that is currently on top of the stack. So we are going to use the value of function that is found inside of the string class, and basically we are just taking the character that is being pointed at by vowel top. Then we are also doing the same thing for the pop consonant method, right? It's exactly the same implementation. We check to see if there's something to pop, right? If there's something to pop, then we are going to go ahead and pop it. Then moving on to the next part of the question, we have part D, which says here that the program first needs to call read data and then prompt the user to input their choice of vowel or a consonant. Then it's also going to take as input the user's choice Depending on the user's choice, pop vowel or pop consonant, and store the return value. The three steps are repeated until 5 letters have been successfully returned and stored. If either stack is empty at any stage, an appropriate message must be output. Once 5 letters have been successfully returned and stored, they are output on one line. For example, there's an example going on there. All right, so maybe one thing that I need to point out is for this particular paper, what you need to do is you need to make sure that you read everything and understand the requirements so that you don't misfire when you are planning, right? So you actually see that you wouldn't know that you are going to use a loop until you get to this part where it says repeated. So you don't want to just read the first part and try and attempt to write the solution. You want to read everything so that you understand the requirements before you can attempt a solution. So let's go ahead and look at this implementation. So my main method is right here on line 76 all the way down to line 108. So we are starting by calling read data, right? Because that's what they said here. We need to call read data first. After which we are going to instantiate a new scanner object. Then from the scanner object, let me just go ahead and remove the system because I did import everything from the system classes, so it's going to work. So we create instantiate a new scanner object on line 79. Then we are using a string builder class and in creating a variable called result, which we are simply going to build or append letters, building our strings as it were. Later on down there on line 100. Then we are initializing the count to 0 so that we can control this while loop. So we are going to say while the count is less than 5, meaning to say that our loop is actually going to run from 0 up to 4, which makes it 5 times. We are going to repeat everything that is inside of this, inside of the body of this while loop as it were. So we are going to prompt the user to enter a choice for their vowel, whether a vowel or a consonant. Then that choice we are simply going to read it using we're going to read it using the scan object right here. Then we take the next line and convert it to lowercase in the event that the user maybe might have the caps lock on. So we want to convert it to lowercase, and again remember that our file only has lowercase letters, so that this is very important. After which then we just store it inside of this choice. Then what we are going to do is we are going to have this string letter variable, that's going to actually hold the popped vowel or consonant as it were. So after that, we are now going to check to see if choice is equal to a vowel or it's equal to a consonant. Then if the letter is depending on either case, right, we are going to run this, the respective pop method. So in the case that it is vowel, then we are going to pop from the vowel stack and store that inside of letter. Then if it is a consonant, we are going to pop from the consonant stack and store it inside of letter. Otherwise, we are simply going to tell the user that it is an invalid choice. Then we are using the word continue so that we can continue running our iterations as it were. Then if the letter is equal to no data, then it means that the stack is empty. So this is where we are now outputting the appropriate message right here. Is it? Then if there is data to append, we're simply going to take the result string that we declared on line, where was it? Line 80. Remember the string builder object right here we created, is it? So we are now appending the current the letter that was popped from the respective stack. So it's whether the vowel stack or the consonant stack. So this is going to happen 5 times, is it? So this is where we are updating count. So remember, count is initially 0. So count is going to be updated right here. Then we now have count of 1, count of 2, count of 3, count of 4. Then our loop is going to terminate. Then after all this, we were told to let's just finish off with we are just outputting the result is both. That's what they want us to do here. Once the 5 letters have been successfully returned, we are going to output the result. So that's what we are doing on line 105 there. And then of course we're just closing the scanner object on line 106. So having done this, you would copy the code and paste it inside of the evidence document. Now we need to test our program with the following inputs. We have vowel, consonant, consonant, vowel, consonant, vowel. Alright, so let me just open the terminal right here and then just scroll so that we see the test where does it go? So you see that I had already tested the program when I was doing it, when I was preparing the solution offline, off screen. But I'm just gonna clear the screen here. Then let me just run the program one more time. Alright, so enter vowel choice. So according to the test data there, we should enter vowel. Then we should enter consonant. Then we should also enter consonant. But what I can simply do is I can just cycle the commands by pressing the up arrow. Then I want consonant, then I want vowel. I can just press up twice and hit enter, then hit enter. Then you see that the result is this. So this is the implementation for question 1 of November 2022 using Java. So yeah, I hope you learned something, and I'll see you guys in the next one.